Last week, you performed a series of experiments on copper. At the end of the lab, you should have ended with copper. In today's experiment, you will determine how pure the copper is, or if there are impurities in the sample. To do this, you will make a set of standard solutions which you know the concentration of. You will measure their absorbances. Then, you will measure the absorbance of your copper from last week and use the standard solution data to find the corresponding concentration. To begin, you will need to dissolve your sample in nitric acid like you did last week. After the reaction is over, add 30 milliliters of water to the beaker. Obtain a 100 milliliter volumetric flask and add about 30 milliliters of water to it. Fold a piece of filter paper into fourths and place it in the funnel so that there are 3 layers on one side and 1 on the other. Use a little water to seal it into place. Now filter your sample through the funnel. You may need to add it in stages if it does not all fit at once. Meanwhile, you will prepare a set of standard solutions. These are solutions which you know the concentration of. You will use these to determine the concentration in the sample from last week. Obtain a stock solution of 0.1 molar copper nitrate, 6 10 milliliter volumetric flasks, and a micropipette set to 2 milliliters. In the first flask, you will place only water. In the second flask, you will place 2 milliliters of copper nitrate. In the third flask, you will place 4 milliliters of copper nitrate, which you can do by using the 2 milliliter pipette twice. Continue with 6, 8, and 10 milliliters of copper solution. Dilute each flask to the line with water. Now, you will need to prepare your spectrometer. First, you will calibrate it with water, step 4A. This tells the spectrometer how much light it should expect when none is absorbed. Fill a cuvette with water about 2/3 of the way and wipe the sides with a Kim wipe before placing it in the spectrometer. Next, you will determine the maximum wavelength, step 4B. This is the wavelength where your sample is absorbing the most light. For this, you will use your most concentrated sample, the one where you added 10 milliliters of copper nitrate. First, rinse the cuvette with a bit of your sample, then pour it in the waste container. Then fill it 2/3 full with your 10 milliliter sample. The spectrometer will identify the wavelength where the most light is absorbed. After this, you will measure the absorbance at that wavelength only. Follow the directions in the lab to change the collection mode to absorbance versus concentration. Now you will measure the absorbance of each of your samples, step 4C. They can be measured in any order. After each sample is placed in the spectrometer, wait for the absorbance to stabilize, then hit keep. Enter the concentration of that sample. Note that the concentration is units of moles per liter, not milliliters. You will need to do a dilution calculation to determine the concentration. During this section, do not hit stop. Just remove your sample, place your next sample in the spectrometer, and hit keep again. Only after you have measured all 6 of your samples should you press stop in order to determine your linear fit line. By now, your copper from last week should be done filtering. You are ready to find the concentration of copper in that sample, step 4D. Dilute the sample to the 100 milliliter line with water. Rinse a cuvette with this sample, then fill it 2/3 full and place it in the spectrometer. You do not need to push any buttons, just read the absorbance in the corner and record it in your lab notebook. Repeat this reading 5 total times. Using the interpolate function, find the concentration that corresponds to the absorbance of your copper sample. This will be based on the data you collected for your standard solutions. Remember, that was the whole point of the standard solutions.